Analog and digital communication. Introduction. Communication of information is a basic human activity. It has been in existence ever since the dawn of life. In ancient times, information was conveyed through well-trained pigeon. Then came the era of messengers who would walk on foot, cart, horse and carry the messages over long distances. With the advancement of technology, new methods of communication have been developed. Communication system. In this communication system, firstly the information source is a rising message signal, and these message signal goes to a transmitter. The transmitter transmits the information after modifying it to a form suitable for transmission. The transmitted signal goes to communication channel. The communication channel carries the modulated wave from the transmitter to the receiver. The receiver receives the received signal, and then these message signals are distributing the user of information. In this type of communication, some noise is arising. A communication system is a setup used in the transmission of information from one place to another. A communication system consists of the following three parts: transmitter, communication channel, receiver, antenna. An antenna is a structure that is capable of radiating electromagnetic waves or receiving them, as the case may be. Basically, an antenna is generally a metallic object, often a wire or collection of wires used to convert high-frequency current into electromagnetic waves and vice versa. Thus, a transmitting antenna converts electrical energy into electromagnetic waves, whereas a receiving antenna converts electromagnetic waves into electrical energy. Basic terminology used in electronic communication system: signal, transducer, noise, transmitter, receiver, attenuation, amplification, range, bandwidth, modulation, demodulation, repeater. Message signals. Message signals are electrical signals generated from the original information to be transmitted using an appropriate transducer. A message signal is a single valued function of time that conveys the information. The function has a unique value at every instant of time. These signals are of two types: analog signals, digital signals. Analog signal. An analog signal is that in which current or voltage value varies continuously. Digital signals. A digital signal is a discontinuous function of time. Amplitude modulation is a amplitude modulator. It is essentially the common emitter amplifier for the carrier wave signals. The base biasing voltage is the sum of DC and modulating signal. The output voltage will be a carrier wave varying in amplitude in accordance with the biasing voltage. This is the amplitude modulated wave at the receiving end of the signal is weak due to attenuation in the channel. The receiver must amplify the received signal first. The signal is usually accompanied by lots of other unwanted signals or noise. Only the desired signal is selected and others are rejected by the receiver. The demodulation is performed in the receiver to recover the original modulating signals. We explain amplitude modulation process using a sinusoidal signal as the modulating signal. Frequency modulation. When a modulation AF wave is superimposed on a high frequency carrier wave in such a way that the amplitude of modulated wave is same as that of the carrier wave, but its frequency is varied in accordance with the instantaneous value of the modulating voltage, the process is called frequency modulation, FM. Pulse code modulation, PCM. Pulse code modulation is a completely digital modulation. The three operations involved are briefly explained now. Sampling. Sampling is the process of generating pulses of zero width or zero duration and of amplitude equal to the instantaneous amplitude of the analog signal. Quantization. Quantization is the process of dividing the maximum amplitude of the analog signal into a fixed number of levels. Coding. The process of digitizing the quantized pulse according to some code, say the binary code which is most popular. Demodulation detection of amplitude modulated wave. Demodulation is the reverse process of modulation which is performed in a receiver to recover the original modulating signal. Data transmission at the digital data transmission and retrieval. In the digital data transmission, the input analog signal is sampled at the suitable rate by the sampler. A quantizer quantizes the sampled pulse. The encoder codes the quantized pulse according to the binary code. The pulse code modulated signals are then modulated by amplitude shift keying or frequency shift keying or phase shift keying and finally transmitted into free space. In the digital data retrieval, the digital signals received are fed to the quantizer. The quantizer of the receiver has to decide about the presence or absence of a pulse. The output of the quantizer is pulse code modulated signal which is fed to decoder. The decoder performs the inverse function of the encoder and gives the output in the form of quantized pulse. And retrieval. In digital communication, the modulating signals are discrete. They are coded representation of the message signal or information to be transmitted. To transmit the digital data through space, following three modulation techniques are used: amplitude shift keying ASK, frequency shift keying FSK, phase shift keying PSK. Modem. A modem is a device that can connect one computer to another across ordinary telephone lines. Types of modems. Three types of modems are in use: internal modem, external modem, PCMCIA. Fax or facsimile. Fax machine. The fax machine, to start with the sender dials in the phone number of fax machine at the receiving end. Its sender's end is set in the transmitting mode and the receiver's end is set in the receiving mode. The document to be transmitted is then fed into the fax machine. An optical scanner scans the document in the form of white and black spots. The amount of light reflected from different parts of the document is detected by the sensors. Where ink is present, much smaller light is reflected, creating an electrical pulse of low voltage. In the portion of white paper, large amount of light is reflected, so creating the electrical pulse of high voltage. A modem converts these digital pulse into analog signals, which are transmitted to receiving fax machine via the telephone lines. At the receiving end, the modem converts the analog signals received back to digital pulse. The printer prints the receiving end and these digital signals in the form of white and black spots to reproduce an exact copy of the original document. The fax or facsimile telegraphy is the electronic transmission and reproduction of a document at a distant place. Space communication. Electromagnetic waves. Electromagnetic waves are those waves in which there is a sinusoidal variation of electric and magnetic field vectors at right angles to each other as well as at right angles to the direction of propagation of waves. Earth's atmosphere. The gaseous envelope surrounding the Earth is called Earth's atmosphere. The Earth's atmosphere mainly consists of nitrogen 78%, oxygen 21%, and with a little portion of argon, carbon dioxide, water vapor, hydrocarbons, sulfur compounds, and dust particles. Troposphere, stratosphere, mesosphere, ionosphere. Radio waves. The radio waves are the electromagnetic waves of frequency ranging from 500 kHz to about 1000 MHz. These waves are used in the field of radio communication. Transmission medium or communication channel. The transmission medium or communication channel is a link through which information or message signal may propagate from the source to the destination without any noise or distortion. Transmission media have been divided into two types: guided transmission medium, unguided transmission medium. Ground or surface wave propagation. It is a mode of wave propagation in which the ground has a strong influence on the propagation of signal waves from the transmitting antenna to receiving antenna. In this propagation, the signal wave glides over the surface of Earth. Sky wave propagation. It is a mode of wave propagation in which the radio waves emitted from the transmitter antenna reach the receiving antenna after reflection by the ionosphere. Important terms for sky wave propagation: plasma frequency and critical frequency, maximum usable frequency MUF, skip distance, fading, refractive index mu of a layer. Space wave propagation. The frequency of the radio wave is greater than 54 MHz. Then these waves cannot travel along the surface of Earth as they get absorbed by the Earth. The communication through space wave between transmitter and receiver is limited to line of sight path. The line of sight path limited by the line of sight distance and the curvature of the earth. The space waves following the line of sight propagation get blocked at some points by the curvature of the earth. Here, dt is called the radio horizon of the transmitting antenna. dm is called the maximum line of sight distance between the two antennas. The range of space wave communication can be increased by increasing the height of transmitting antenna and receiving antenna. Propagation. It is that mode of wave propagation in which the radio waves emitted from the transmitter antenna reach the receiving antenna through space. These radio waves are called space waves. The space waves are the radio waves of frequency range from 54 MHz to 4.2 GHz. Satellite is sent directly towards the satellite, which receives the coming signal, amplifies, and returns it to Earth station receiver at a different frequency to avoid interference between the uplink and downlink. These frequencies are in UHF or microwave region. Hence, they can cross the ionosphere of the Earth and reach the satellite, which is situated in the ionosphere. The signal received by receiver is generally weak. It is amplified by the receiver and then it is televised. Communication. The satellite communication is a mode of communication of signal between transmitter and receiver through satellite. The satellite communication is like the line of sight microwave communication. Line communication. The wire systems which have properties that cannot be ignored are called transmission lines. The sizes of the wires and their general layout become significant when transmission is at high frequencies or low wavelengths. The most commonly used two wire lines are parallel wire lines, twisted wire lines, coaxial wire lines. Two metallic wires run parallel to each other inside a protective insulating PVC coating. The metallic wires may be flexible or hard depending on the power to be handled. The signal flowing through the wires create their electric field E and magnetic field H. In this animation, the solid line represent electric field and dotted lines represent the magnetic fields. The impedances of the detecting device at the receiver is matched to the impedances of the transmission line. Maximum power is transferred to the load. They are most suitable for connecting the TV to the receiver antenna. Characteristics, impedance of transmission line. The characteristic impedance of a transmission line Z0 is defined as the impedance measured at the input of this line when its length is infinite. Losses in transmission lines. The energy supplied to a transmission line may be dissipated in the following three ways: radiation losses, conductor heating, dielectric heating. Optical communication. It is a mode of communication by which we can transfer the information from one place to another through optical carrier waves. Optical fiber. Optical fiber. It has three main parts: The central core is the innermost core of the optical fiber. It is made up of thin and fine quality transparent glass, polymer or dielectric. Cladding is the layer made of glass or plastic which surrounds the central core of the optical fiber. The central core and cladding are enclosed in a protective jacket is called plastic jacket or buffer coating. It is made of plastic and it providing safety and strength to the optical fiber. The optical fibers are used as cables to transmit light signals from one place to another without any appreciable loss in intensity of light signal. The following main parts: central core, cladding, plastic jacket or buffer coating. Types of optical fibers. There are three types of optical fiber configuration: single mode step index fiber, multi-mode step index fiber, multi-mode graded index fiber. Optical sources for communication links. Lighting of light through optical fiber. Considering a ray of light traveling through the core of optical fiber, it is incident on the core cladding interface at an angle of incidence theta I. A part of incident ray will be reflected and the remaining part of the incident ray is refracted in the cladding at an angle of the refraction theta r. The ray of light entering the core will always meet the core cladding boundary at an angle greater than the critical angle. The ray of light will suffer total internal reflection. There will be successive total internal reflection at opposite boundaries of core cladding surface, due to which the ray of light will be confined in the core of optical fiber and emerges out with maximum intensity. Light emitting diode. A light emitting diode is a semiconductor PN junction diode which emits spontaneous radiations when forward biased. Laser. The working of the laser is mainly in the following steps. When an atom in the ground state absorbs one of the photons, it is raised to the excited state. The atom in the excited state may decay spontaneously, emitting a photon of energy h. Nu is equal to E2 minus E1 in any arbitrary direction. This is called spontaneous emission. The incident photon may interact with the atom in the excited state and induce it to emit the photon of the energy h. Nu is equal to E2 minus E1 exactly in the same phase and in the same direction as the incident photon. This is called induced emission or stimulated emission. Then the population inversion takes place. The phenomenon of making the atoms in higher energy state more than the lower energy state by induced absorption is called population inversion. Thus, the incident photons of energy interact with large number of atoms in the state. All these photons are in phase and hence produce a very intense beam. Laser stands for light amplification by stimulated emission of radiation. The working of a laser is based on stimulated emission of radiation, and population inversion. Main components of a laser. To produce a laser beam, the laser system has three main components: active medium A, pump P, resonator guide. Lasers are of four types: gas lasers, solid lasers, liquid lasers, semiconducting lasers. Light modulation. It is a process of varying the intensity of light directly in accordance with the information signal like speech, music, digital code, etc. available in the form of electrical signal. Optical detector. The detector is a device which is employed to isolate the information signal from light modulate signal reaching the receiver. Communication system. The input analog signal is first sampled and modulated using pulse code modulation, which results desiccate pulses and gives coded streams of bits representing the signal. In stream bit, the optical beam from a source is modulated, producing modulated optical signal. This modulated signal propagated through a medium called optical fiber. At the receiver, the optical modulated signal is detected by optical detector. It converted the optical modulated signal into electrical signal. This signal is further decoded, producing thereby the original information signal, that is analog signal, is reconstructed, which is then received at the destination. Optical communication system. The optical communication system is that system of communication in which we use the optical carrier waves for the transmission of information from one place to another. In optical communication system, signal is transmitted in the form of light pulses along an optical fiber as transmission medium.